продолжаем с нашими докладами. Только что мы прослушали про языковые модели.
We are continuing with our presentations. We've just heard about large language models.
Датасеты, чтобы машины понимали лучше.
They had prepared special data sets so that machines should understand better what we meant. And now we're going to prepare data and tools for ourselves to understand better what we mean. So welcome Andrei Popov with a presentation.
Спасибо за представление.
Thank you for the
На
introduction.
самом деле емко.
Actually, that was quite a good description of what I'm going to talk about. I have quite a lot of material, so I suggest we get straight to the point.
Давайте знакомиться.
Let me introduce myself.
Соответственно, работаю в компании Positive Technologies.
I work for Positive Technologies,
Работа заключается в
and the essence of our work is to get knowledge from data.
Я занимаюсь уже больше 15 лет.
I have been working with Python for more than 15 years,
Тут уже было.
and our data engineering team now counts more than 20 people.
Данные — это у нас информация об уязвимостях.
Data is, for us, it's information about vulnerabilities, more than 100 pipelines, millions of documents, JSON, unstructured data, data feeds, BD dumps, and so on and so forth.
Начнем мы доклад с типичных
Let's start with a typical architecture
потоков данных на производстве.
of data flows in production.
Оперируют большим
So not only such systems operate with a large number of data,
количеством источников данных.
also the number of data sources
В мире у нас
is growing. And in the modern world,
данных за счет того, что
will
часть
also
данных будет
get data
на,
through some data being generated by the artificial intelligence.
каким образом мы можем находить
How
противоречия,
can we find contradictions in all these things?
чтобы данные были консистентны?
How to make sure that the data is
И
consistent,
в ближайшие полчаса пойдет
not contradictory?
центральной части.
So, in the next half hour, we're going to talk about the central part of this system, which is designated here as a real database.
Доверие к данным.
So the biggest question is how to increase trust to the data stored there, and how to derive new value from what
Получится
we have there.
весь тот огород,
And as a bonus, we'll be able to simplify all the situation that we get around data processing.
достаточно известная пирамидка, и все же пора
Quite a well-known pyramid, but still I'll mention a couple of words about it. It's hierarchic models that describe the process of converting data into knowledge.
находится
At the bottom level of this pyramid, you have raw data. They don't have a lot of value to them. At level 2, we are enriching it, have enriched them with some context, structured them, and can use
можем найти
them in real products, can find use for them.
и знание
So it's information. And knowledge is the third level,
объединяет информацию для
the third layer that brings together information in order
и
to generate understanding and
мы
importance.
как раз будем во время доклада
So we are going to
вторым и третьим уровнем, то есть из информации
switch between level 2 and level 3 in this pyramid. So we'll be deriving knowledge from information.
получили данные
So we've collected data
форматов, в
from
котором
somewhere, we structured them, brought them to the format that can be used, and
находимся
we are now
на этапе перехода к
at the phase
знаниям, и сейчас посмотрим, как
of converting them to knowledge. And we'll now see how
могут нам
a graph
решить вопрос
knowledge
доверия и
bases
получения знаний.
will help us solve the questions of trust and deriving new knowledge.
Граф знаний
Firstly, what's a knowledge
—
graph?
это направленный граф, который
A knowledge graph or a semantic model is a directed graph that's a network of real world objects.
связи между ними.
There's objects, events, and connections between them.
Компонентов, как и
It consists of three main components, just like any graph.
любой объект или человек
Nodes, edges, and tags. Any object or person can be a node. An edge defines connection between nodes. For instance, a customer or company can be a node, and the edge
отношения
would characterize the relationship between these two nodes.
Помимо хранения знаний,
Apart from holding knowledge,
в области искусственного интеллекта, рекомендательных систем, чат-ботов,
so it's becoming more and more popular in the area of AI, recommendation system, chatbots, and also now the much hyped GPT chat also use knowledge graphs.
Ранее нам нужны в том
In the general form, knowledge graphs are needed when the connections between entities are of more value than entities themselves.
Вот на картинке пример
So
одного из
we see this picture.
графов.
It's an example of
Используется, то есть
a real-life graph
в презентации
that we use.
весьма
Actually, my presentation will
пример для того, чтобы
be based on quite a simplified example
в реальном мире они
to give you more understanding. But in real world, they look quite frighteningly. But there are tools that allow working with real-life cases to shape them,
работать с графами
to process them. So as a result, we learn how to work with knowledge graphs, create ontologies, get information about ontologies, to load data in
делать
graph
запросы
format,
в Sparkle, делать новые выводы по данным, визуализировать результаты нашей
to make new conclusions based on data, visualize the results, and
в которые это все позволяет делать.
also to
Предлагаю
get introduced to some Python tools that allow us doing that. So there's a lot of content. I suggest that we move fast. Firstly, what's the relationship between a database and a knowledge base?
соответственно, рассказал то, что сущность
I've already covered the first one. So the entities are
в реляционках
stored as nodes and edges or graphs, whereas in relation database, these are lines and columns and tables. In databases, the data, the knowledge stored without any strict schemas. In databases, we use relational databases. Knowledge bases
на сущностях.
are based on connections between entities, whereas databases on entities as such.
Если
There's also this hypothesis of open and closed world. What does it mean? If some information is missing in a database, the database will return you yes or no. So if there's no employee record, that it means for it that the employee is not working in the company.
в
The knowledge base
об открытом мире,
runs
всё о том, о чем у нас нет
on the
информации,
premise of an open world. So anything that we don't have information about comes as a known. So basically the possible answers are yes, no, I don't know.
концепциях.
Let me now cover which main concepts are used
Первое это
for knowledge graphs.
URI.
The first one is URI, URL. All entities
Знаний
kept in a knowledge base are identified using URI,
расшифровывается как Unified Resource
Unified Resource Locator, URL. The main difference
от того же
of URI
баз данных
from the primary key in database
глобально уникальны.
is that they should be globally
Не в
unique.
пределах графов, не в пределах компании.
Unique not within a graph or within a company, but unique worldwide, so
Добиться можно
universe-wide.
тем же
This can be achieved using the same tools that we use for websites. So URL, you have a domain, and for that domain,
вы можете навешивать уже
you
URI,
can
который будет
add a URI that will
гарантировать.
guarantee with a large degree of probability that it's unique.
Это то же самое, только там можно
IRI, it's the same thing, but you can also use non-ASCII symbols. There are also two great things called having the same name,
это
but they mean absolutely different things. They're both called pearls.
Persistent Uniform
First one is a persistent uniform resource locator,
позволяет отвязать
which allows unlinking
непосредственно владельца домена
the owner of a domain from
от этих ключей, там, где
from these keys
антология или словарь.
that holds some ontology or dictionary. It's very convenient for those things that have already become part of the public domain.
Там уже
So a lot of things.
и все неизвестно, домен забрал.
So the domain has been taken by someone else. So the owner is not known, but ontologies and dictionaries still refer to this pearl. persistent uniform resource locator.
Это
The second one
тоже называется PURL. Это
also bears the name of Perl,
как package URL. Это стандарт,
but it's
стандартизированный
a
однозначно
standard that allows
компоненты программного обеспечения. Их
identify software components in an unequivocal way.
версия, название, то есть у нас
The version, name,
разных пакетных менеджеров.
there are lots of other packet managers, lots of software.
Все как-то дело стандартизировать. Вот
There have been
пользуется в стандарте.
many attempts to do that. Perl is actually used in BOM standards and Cyclone DX. These things can also be used as URI.
Мы будем, прошу обратить внимание на
Also, please note, please pay attention to the part of the URI called namespace, because it's also an important concept in knowledge graphs.
вот. Если все будут придерживаться таких
So, if everybody observes the same rules, then in theory we can create a single graph with all knowledge,
будет
so that
однозначно связано с
a subject,
графом.
for instance, the author of the book, will be unequivocally linked to an article in Wikipedia with the specific book, and by this book you can find the publishing house and so on and so forth. There are such initiatives such as DBtasia and Wikidata. By the way, if somebody needs information in graph format to take a look and experiment with it, these are very useful
Случай, когда это не получилось.
public resources we can take it. But maybe it's good that not everybody has been able to arrive at an agreement which makes
Мы немного отсрочили.
the
Однако в практическом применении
problem of ChatGPT conquering the world a little bit more difficult.
внутри компании,
So we're not yet at the judgment day. But within a company, it's quite easy to do.
домен
And if there's also a large public graph domain
смело
that
пользоваться.
we can boldly use.
То есть, если кто-то разработал,
So if somebody has developed some dictionary or ontology,
пользоваться публичными наработками,
you can use public developments, expanding them, adjusting to yourself so that you shouldn't reinvent the wheel.
пам-пам. Триплеты.
Triplets.
Основное
main-
хранение данных
At atom of data storage in a knowledge base is a triplet.
предложением состоит
Every entity is represented by a sentence which has three parts: subject, predicate, object.
в обычном языке это тоже является
In common language, this is also one of the fundamental constructs
триплет используется для
in
описания
speech. Every triplet
и в целом
is used to describe one fact, and basically can put a full stop here.
все
So URL triplet is alpha and omega of knowledge base. All the rest is done using some frameworks. All these frameworks, they're all based on these basic principles.
Триплет это также
triplet.
нормализация базы нормализация
Also
форма, возведенная просто в абсолют.
allows is about normalization brought to the absolute form. In this format,
Источников прям
data can be loaded from any sources just into a single table,
не будет никаких конфликтов.
and you're not going to have any conflicts.
Много без одной
But there's not much sense in it without one very useful thing.
антология.
I'm talking about ontology.
Формальное определение.
This is the formal definition of the ontology. You can read it yourselves. Sounds frighteningly, but in fact, it's not exactly a frightening thing.
Обычно такая схема состоит из
Usually, this
содержания
scheme contains of the structure of data that contain all the relevant object classes, their connections, rules, theorems, constraints that are adopted in some specific area.
построение антологий.
Building ontologies
Мы занимаемся
is, in essence, what we do at the stage of developing software,
то есть мы
the stage of software design.
диаграммы, UML классы, их
So we build EID diagrams, class diagrams, attributes, dependencies,
алгоритмы,
operational logic, rules, algorithms, everything
инстанцирование
except
рантайма.
instancing and runtime.
То есть онтология описывает, как
So ontology describes how everything interacts at the level of abstracts.
хорошая новость состоит в том,
And the
что
good news
онтология
is that ontology can also be described using triplets,
замечательно.
and everything will be
Также для
fine.
онтологии очень важно понятие
Also, the concept of domain is very important for ontology, the domain for which we're building this ontology. Because even within one organization, such an entity as a customer can have absolutely different meanings for different departments. So for the sales department, the customer is those who have purchased a complete product or has probably, and for technical support, the customer can be an internal customer if they're offering support for internal users.
домен плюс
So the question about the domain is important.
данных.
Domain plus data structures, schemes, and logical work. Ontology is all about that.
Первый уровень,
Level one
который мы можем наложить на наши триплеты, это
of formalization that we can impose on our triplets is RDF. It's a framework. It's also described in the triplet format. It's a resource description framework. It adds some additional data structures apart from triplets, of which the most important are predicate and RDF type. It's used to describe types of entities. RDF schema defines more classes that define subjects, objects, predicates, and so on. It means that you can already make statements about classes, entities, and types of interactions, of relationships. The closest ontologies are ERD model and UML model.
Переходим к такой штуке, как
Now moving to the things called OWL, OWL. OWL expands as a web ontology language.
уже в нашу схему семантику, она позволяет
So it adds semantics to our schematic. It shows a lot more attribute properties of classes, and it can also be expressed.
начать описывать всякого рода
You can also start describing all sorts of rules. If the subject
субъект,
is married to co-subject B, then subject B is also married to subject A.
все в этом духе. То есть взаимоотношения
And same thing. So it's about relationships,
дети-родители,
like parent to child, inverse relationship, transitivity, functionality, and other things.
соответственно, почему антологий
So why
FOVL так много? Здесь
there are so many OWL ontologies?
вопрос в
The whole question
выразительности и способности
is about
антологии выражать сложные
the ability of the language to express relationships between complex entities. You can build an ontology that will describe some subject area in a very detailed way, but it won't be computable, because in the general case, it's the task of identifying the path.
данные.
Sometimes we, at the expense of expressibility, we build an ontology with less strict rules, but we improve the computability. But then, at the expense of expressiveness.
Если тоже приводить здесь аналогию,
To use an analogy,
книжки с правилами.
When you buy a board game,
OVL это как раз
it comes with a rule book. So in the first approximation, OWL is the rule book for a board game.
соответственно, эта книга, она тоже
So this
самое, она описывает домен.
book does exactly the same. It describes the domain and the rules that should be used in this domain.
Тема.
So a demo now.
Сейчас мы с вами создадим антологию
We're now going to create an ontology using OWL already.
с помощью
Take a look at the ontology using AutoSpy. We'll do some work with RDFlib. Then
Сделаем шейпинг.
we'll do the shaping.
Данные с помощью PyShackle.
Same as data validation using PyShackle. Do several Sparkle requests to visualize all this.
Уровне
Make
RDFS.
conclusions at the RDFS level.
Узнаем новое с помощью
Learn new things with the help of OWL and visualize the result. So let's go.
опять же на понятном языке. Мы
Again, in understandable language, we model such a simple system. We have software,
У нас есть
we have,
библиотека, это тоже софт, поэтому это
well, a library. A library is also software, therefore we have
библиотека. У нас
this
какой-то
dependency,
и нам нужно вывести второй.
inheritance, and there's some vulnerability, and we need to find the relationship that the software is also vulnerable.
Импорта, ничего интересного. Хотя нет, есть чуть интересного. Соответственно, вот здесь описано.
So, what's there of interest? Here we describe namespaces. We have set them as constant.
Это для нашей
Then
схемы,
the first namespace is for our schematic, and the second namespace
для инстансов.
is for the instances.
С помощью
Like this.
фреймворка
Using
Ready 2
the OWL Ready 2 framework, we can describe our ontology right in Python.
что я сделал,
And
это
what I've done,
просто перенес в класс.
I just transferred this image to classes.
Несколько RDF
I added several RDF properties
и написал то, что
and said
библиотека
that the library
в домене софтвера
in the software domain,
софты используют библиотеки.
that software uses libraries and that libraries are being used by software. And so with vulnerabilities also, I
Это мы прям сразу можем
specified two simple
что у нас получилось. Это
dependencies.
XML.
So we can look it up and see what we got. It's XML. We don't have enough time to read XML. We will use another tool. It's called OntoSpy. It allows bringing up high-level information about ontology. So we see which namespaces are used here.
Соответственно, вот
Correspondingly,
мы сверху, и вот этот стандарт.
we're at the top.
Их, в принципе,
And these are the standard namespaces. You can also look them up.
вот
For instance, RDF, RDFS, these are dictionaries just like others. They also define classes and properties, and we have defined the following hierarchy: software, then a library inheriting from it, and vulnerabilities. And we have these properties. As connections, affected required value. Let's go to RDFlib. Using RDFlib,
предикат объект.
you can build this graph.
Опять же, пока не очень красиво. Это
Doesn't look nice yet. It's because we haven't sorted out with namespaces. In RDFlib, there's a concept of namespace manager.
и их
You
сокращение.
can output all namespaces and their acronyms.
Последний вот нам не сильно нравится.
So we would like the last one very much.
Точно так же можно с помощью
But
спая посмотреть. Вот.
you can derive something like that from here with OntoSpies.
Да, то есть вот
Not too much information.
type value.
First range, RF type value.
Соответственно, вот этот блок кода, что он делает?
So this block of code, what does it do?
Схему, которую мы сгенерировали из классов.
It treats the schema that we generated from the classes. It takes namespaces and binds one to the other. After which
Выводить
we can
в более
output our triplets in a more acceptable form.
совсем
And so they should be output in the form that is really acceptable.
делаем. Кстати, хорошо.
And by the way, can you see well?
Presentation, вот.
I'm in presentation mode.
Чтобы вы не выводились в хорошем виде, напишу небольшой...
So let me insert an operator that will immediately read them out, put them out in Panda to improve readability. Subject, predicate, object. You see that?
Граф мы также можем сериализовать в формате Turtle.
We also can build a graph in the turtle format.
Это формат тоже записи субъекта, предиката, объекта.
This is also a format with subject,
Должен быть достаточно
predicate, and object.
этих всех отступов.
And
Мы один раз пишем
the essence here is that we mention the subject once,
до следующей точки.
and then
Субъект
until the next dot, we don't repeat the subject and just mention other predicates and objects that are bound to the subject. So this is that the library is class, and so on and so forth.
фильтрануть. Мы можем фильтрануть
How can we filter it? So we can filter,
URI reference и
we can create a URI reference
соответственно у нас вылезут
by type,
только все
and
ответы, где
we'll get only the triplets where the predicate is type.
также с помощью
Also,
либо мы можем
using RDFlib,
namespace.
we can get the namespaces
Точно так же все фильтруется.
and do filter by them in the same way. We'll also graph that.
Мы разобрались.
So we've sorted it out with the schema. Let's now load the data.
Выглядит вот так.
The data looks like this,
Turtle — это
again in the turtle format.
уязвимость, библиотека.
Some vulnerability, library, and program.
Секунду, вернусь в презентацию.
Software, that is.
Будем
Let me come back to the presentation because we'll be...
Ой-ой. Заниматься шейпингом.
We will be doing some shaping.
По сути, валидация
Shaping is,
и задание
in essence,
компоненты
validation.
графа.
And we're putting thresholds on the graph
Типы значений,
components.
разрешенное количество предиктатов.
Types of values, allowed number of predicates, combinations of predicates, length of a string, etc.
Шейперы у нас пишутся тоже
Shapers are
с
written
помощью триплетов.
with triplets.
Сверху это определение у нас
On top, you see the definition of a contour.
внутри это непосредственно target class.
Inside, we have a target class and limitations that we impose.
То есть здесь
here.
у нас написано то, что
So here we have
должен иметь
that software must have
тайтла.
at least a title.
Возвращаемся в ноутбук.
Let's get back to our Jupyter Notebook. As you may see, in here,
Так. Сейчас.
let me take a look.
Дата. Сейчас мы посмотрим, как актуально у нас шакл. Да.
Yep.
У нас софт должен иметь title.
Software must have a title like a string,
Только один.
and the title should be just one.
Загружаем этот шакл в граф и производим валидацию.
Putting it into the graph and doing validation.
Соответственно, видим ошибки валидации.
So we see validation error,
У нас,
validation report,
data type не соответствует, максимальное количество.
data type is wrong,
и сущность, которая не
maximum length, and the entity that did not
нормальные
work.
данные и повторим все.
Now let's slow it normal data and do the same thing.
Пам-пам. Ну, соответственно, валидация прошла нормально. И
Validation went fine,
у нас был
and validator was satisfied.
Sparkle.
Now let's continue with Sparkle.
Sparkle — это язык запроса.
Sparkle is a language, the query language.
Опять та же самая, триплеты. Знак вопроса.
Same essence, triplets.
Вернет все триплеты, попадающие под маску. То есть это любой субъект
So all of the triplets that fall
и любой
into
объект.
the mask, any triplet, predicate, or DF type,
Дальше
any object.
Sparkle 101. Можно
So
делать
Sparkle
select,
101.
можно делать
You can do select, you can do describe,
это
ask
новое
like select,
возвращается
returns true or false.
ask. Это как select, но возвращает true false. Можно сделать constructed, когда результатом
You can have construct
создается граф.
when the result is the graph.
И delete.
You can do insert, delete.
Bind работает
Queries.
как качество
Bind
SQL,
works as
фильтр
cast
работает как
in
where в
SQL.
SQL,
Filter
поддерживает
works as where in
всё, к чему мы
SQL.
привыкли. Order by,
Supports
group by.
order by, group by. Supports
запрос.
union and subqueries.
Соответственно, сейчас на примерах мы посмотрим несколько.
Let me show you a few examples.
Ну,
A few
во-первых,
Sparkle
приведем
queries.
там весь датасет.
First of all, we will show you the entire data set, all of the predicate subjects, and that's it.
Джойны как работают.
Joins, this is the way they work.
Мы, соответственно, вот в этот субъект складываем все записи, которые попадают.
Here's a subject where we store all of the records according to the mask.
По этому субъекту.
And then we're joined by this subject.
Ну и так далее. Джойны устроены немного по-другому. То есть
Here join is a bit different. RDFS class software. And here
мы выбрали все.
we have picked everything where the subject is a library.
Библиотека у нас
Meaning,
является
A library is
программное обеспечение.
subclass
Мы её
of the
выбрали
software.
и вывели
We
всю
picked it
информацию.
and we output all of the info on it.
Также есть конструкция values, которая позволяет задать
There are also values construction,
переменных в одну сложить.
which allows to set a few variables into one.
Bind, с
There's
помощью которой
bind
производится
construction,
кастинг.
using which we can do casting.
Есть
There is also there are also distincts.
тут еще пару примеров Sparkle.
Let me show you a couple of more examples of Sparkle requests.
Ну, время поджимает, поэтому мы их
Time is running out, so let's run quickly through them.
производится с помощью
Visualization of Sparkle queries is done with PyWiz.
простой код, просто пробегаем.
Quite a simple piece of code. Let's just run down the results of the query, and we create a network.
Украшательством она
With a few beautification, that's the way it looks like.
PyVis нам позволяет
PyWiz allows us to
с этим поиграться.
play it in different ways, play with it in different ways.
Вот. Поиграть.
And yeah, we can play with it, as I said,
Собственно,
and we can take a look
представляет.
what this graph is about.
Вот запрос describe, он вывел у нас всю сущность.
That's describe query that shows the entire entity
Сущность, вот наша уязвимость и ее связь.
of our vulnerability and its connections and its ties.
Reasoning.
Reasoning.
Это процесс
This is the process
превращения неявного
of transferring
то есть на-
non-explicit information into explicit information.
и
At the first level, we can use our scheme and make reasoning based on domain and range. When we were creating ontology, we created a range and a class
Таким образом,
and the classes,
если у нас
our classes, so that if we
предикат affected by, то мы
have
можем по
affected by predicate, we can infer that
объект это software.
the object here is a piece of software
У нас
and the subject is
вернемся в ноут,
vulnerability. If we go back to the notebook, you will be able to see that.
то здесь мы не
So
увидим,
here,
что у нас
we will not see that
мы верим то, что уязвимость это типа
we see that vulnerability
после
is a thing, it's something.
inference.
After we start inference,
У нас сразу появилось много чего интересного. То есть
we
вот этим
get a few cool things right away. This is the way
достроил
we've been able to build
о том, что это
additional
является уязвимым.
fact that this actually is vulnerability.
Дальше
Next,
поговорим по поводу аксиоматики, которая добавляет...
let's talk about axiomatics that's being added by VL. One of them
Chain. Это можно
is
использовать
property
в
chain.
свойств.
This can be used as a property, a chain of properties. I mean, if we want to find relationship affected by between vulnerability and the software, which uses the library where we've been able to find vulnerability.
OVL,
So we can write axiom here
affected by,
that affected by is displayed in the following way.
affected by,
Requires affected by, and we add this class.
то есть прослеживаем путь по графу.
We can track the graphs here.
Inverse properties — это
Inverse properties,
штука.
a second thing.
Пам-пам. Так. Inverse properties — это вторая
Inverse
штука.
properties is a second thing
Которая
here,
немного попроще, она
which is a little
отзеркаливает
simpler.
свойства. То есть
It
если
mirrors properties, meaning that if
программное обеспечение,
the software,
библиотека используется в программном обеспечении, то мы с помощью
the library is using software with inverse property, will be able to find out
программное обеспечение необходима эта библиотека. Собственно,
that the software needs this library.
загрузим они.
These are the roles that we're going to upload. They are described in a TTL format.
Вот они. Достаточно все просто.
It's quite straightforward and simple.
Чтобы не было.
Let's rerun the cell.
Соответственно, вот у нас уязвимость в изначальном виде. Это thing.
So we have thing,
Affected my library.
affected my library, and there's a title to that as well.
И вот my library. Запускаем.
And here's my library. We start our reasoner,
Смотрим, что у нас получилось.
and we see what we get.
У нас получилось, что
We see that
my program affected by
affected by
вот эту уязвимость.
this thingy, this vulnerability here. So before,
Допустим,
I mean, if we launch here describe,
видим то, что
we can see that it
it
affects my library.
Граф, в общем, у нас получился.
And the graph naturally is like that.
Пам-пам-пам. Сейчас наша свеха.
Here's our SVE.
То есть это таким несложным способом
This is a simple way with a couple of
мы
rules.
выяснили
We've been able to find out,
отношение, ну такое отношение.
we've been able to find this kind of a
Выводили мы это с помощью
affected by relationship.
OVL.
We've done that using OWLRL-PY library.
Хотел бы отметить, что
And let me note
не
here
самая
that
быстрая библиотека.
this is not the fastest library, but it has
инструментов, которыми
as many other tools that I'm showing here. It has other value to it.
Если смотреть слева,
If we look from left to right,
в стандарте.
it's like all of those things described in the standards.
Все неподготовленному человеку не понять, да? С другой стороны, если у нас есть под рукой...
You cannot just read it right away, but if you have at hand the library that can implement this functionality, then we can pretty easily figure out
Достаточно легко разберемся, что, собственно, здесь имелось в виду. Это нам
what is going on
понять
here.
какие-то
And we'll be able to understand
стандарты,
that by certain documents, standards,
как работают алгоритмы, как это все...
see how the algorithm works and how this whole computation works. The second value
Это в том, что
is that
мы здесь...
here
Никто не мешает нам вот в этом конкретном коде.
there's nothing that's standing in the way for us in this particular code.
Вот в этом конкретном коде описать факт о том, что
Describe the fact that this particular fact was found with deduction
с помощью дедукции URL PY. И таким
URL
образом
PY
мы сможем
and
обеспечить на всем нашем графике
OWLRL PY.
другие факты.
So when we describe facts with other facts, we can know that this fact was brought to us by ETL system, and another fact was deduced, and another fact was actually conjured by the ML.
Мы можем лучше
We can, therefore, provide better
качество знаний в наших графах.
better quality of knowledge to our graph.
Здесь отдельный
For that,
RDF,
we use here RDF star framework,
который тоже
OWL RL star. You can also OWL star. You can check it online. So, problems to what I told you about. There are a lot of delicacies here.
пробежались по теме.
We actually ran through the subject very briefly. And these are the framework RDF star or L star,
Что есть в стандартных namespace.
asterisk, I mean. And all of these links are clickable. You can read descriptions of standards there. You can take a look at graph algorithms.
Рекомендую ASTAR, Fast Forward.
I recommend A asterisk and fast forward. Also look at the graph embeddings when we split apart graphs into matrices and start some deep learning
Крутая
stuff.
штука.
PyKeen, cool stuff.
И федерализация.
R2ML, RML, and federalization are the things that allow, using mapping, on the fly, or with EDL processes, create graphs of knowledge.
Описываем определенный маппинг и
So we
работаем
take the graph, we describe the mapping, and we work with the database as though it's a virtual graph. Or we take ETL.
экспертные системы.
Business rules,
Это,
expert systems.
То тоже рули, ну, которые, в принципе, можно переписать на питоне.
We can rewrite that to Python. Graphs are also used in process mining. There's a very powerful reasoner called Hermit PDDL.
Это тоже отдельная тема.
That's another subject in itself, but
Рядом тут лежит.
it's very related. Also, we can look at different graph-related stories, GraphQL and LPG. They solve slightly different problems.
Немного другие задачи. Интересно посмотреть как раз отличия.
It's curious to see the differences between RDF-based system from GraphQL and LPG systems.
Вот. В заключение,
In conclusion, let me tell you that we began with knowledge graphs that allows you to organize information from different sources as triplets. We can
и начать извлекать данные.
expose a scheme upon it, and then we can extract data.
По-моему, это также несколько претендует
I
на
think
какую-то точку,
it
где
claims
не только данные,
to
но
be
и
a point that
технологии.
puts
Это
together not only data but also technology that is very commonly used now in machine learning and other subject-based domains. People create global knowledge graphs, corporate knowledge graphs, particular knowledge graphs to work with the language.
К этому это все достаточно просто.
All of these things are quite simple to query.
Интеграция с
There's
базой
integration with
данных.
databases.
Если с чем-то нет интеграции, то
And if there's no integration to
предметной
something,
областью и
that's a
делать
subject
поэтому
field.
методологию.
And we can make ontology for that.
И данное направление сейчас активно входит в тренд.
Another
Есть очень большой простор
trendy thing,
творчества, а главное
a
потенциал
lot
для
of room
создания
for
ценности.
creativity and a potential to create value
Данных, которые у нас есть, это
out of the data that we have, which is database logs. We can upload here
элементарнейшим образом.
elementary, very easily thing. We can download here something, upload here something.
Или уже
If you understand the subject matter, or there is ontology that's ready-made,
то это прям халява.
that's just
Соответственно,
free money.
слайд про QR-код. Первый QR-код.
Speaking about QR code,
Ссылочки из презентации. Я туда выложу также ноут.
links from the presentation, I will upload the notebook
Немного
too.
времени, чтобы поподробнее рассказать. Самим можно все позапускать, все запускабельно. Надеюсь, у меня получилось сделать так, чтобы
I hope I've been able to
с этими графами антологии
get you familiar with these ontology graphs.
стартовую точку. А те, кто были знакомы,
If you knew, if you were familiar, probably you
соответственно, второй
have been able to find out something new.
QR-код для оценки доклада.
Second code is QR code to
Если вы
evaluate this presentation.
вынесли для себя что-то полезное,
If you've been able to convey something useful out of it,
заходите, ставьте лайк. А сейчас вопрос.
please like and share. Now Q&A. Thank
Похлопаем,
you.
похлопаем. Прям мощный теоретический доклад.
A powerful theoretical presentation,
Я скажу,
isn't
что
it?
не
Let me
всё
tell you that
флешбеки
I
из пролога.
probably have not understand everything, flashbacks from Prolog, but when I saw Shaka Library, I realized that
У нас прям
we're
чуть-чуть
all
время
walking
на
in the
парочку
same line.
вопросов. Вот давайте вот
We have very little time for a couple of questions.
Да, большое спасибо за доклад.
Thank you for the
На моем
presentation.
первом месте работы мы разрабатывали
In my first job, we were developing a product.
Загружается моделька Revitus.
We uploaded Carivitas model there from
и она
Autodesk, and
проверяет,
it
что все
checks
материалы, они
that all of the construction materials.
и мы проверяли, что
It was checking that all of the construction materials
обои на стекла и так далее.
are used appropriately, that we're not putting wallpapers over windows.
Тоже Savina,
So we also had the knowledge base on OWL under the hood, but it was filled in by our construction experts. And the best that they could deliver is that they were not really familiar even with the computer. They could not code anything, and you cannot write in raw OWL. It's a big XML extension. We needed tools. We selected Protege because we have not been able to figure out anything better, but there still was a range of problems. First is that somehow we needed to, in a collective way, I mean, there are many experts, we need to somehow maintain one unified database. So in the end, they even taught people to use Git. In addition, the convenience of database, maybe you've faced this kind of problem. If yes, how did you solve it? And maybe you can give a piece of advice on tools for that. Thank you.
Тут важно отметить...
It's important to note here that the graph itself,
Здесь у вас проблема именно с самой...
I mean-
То есть у вас, получается, либо ремонтники сами составляли антологию, либо... у вас
so your guys were making ontology, or
антология.
your ontology was designed in the wrong way. If your ontology was designed in the wrong way, you need to design it in the right way.
Потом
And in addition to that,
Shackle и Reasoner,
using Shackle and Reasoners, you should achieve that the data there are not contradicting one another. The knowledge can be correct, but people cannot do it via code. That needs to be filled in manually, and it's just not convenient. How do you do that?
Тот же Sparkle позволяет делать
Sparkle allows you to make inserts and updates
и вполне себе
for the queries, and you can
REST API, и все заполняется.
Хорошо, спасибо.
write REST IP and fill it in.
Быстренько можно вот на тот вопрос ответить.
Maybe one quick question.
Сейчас к вам подбегут.
Еще как вариант, они могут заполнять куда угодно.
Another
а
option,
потом, с помощью
Your guys can fill it in anywhere and then use RML and mapping,
Они могут
and you
заполнять
transfer that.
вариационку, где вы уж наверняка будете гарантировать.
They can do something relational where you can guarantee
Туда, где надо, то, что надо, а вы потом аккуратненько...
where they filled in what they're supposed to fill in, and then you carefully grasp that into, drag that into the graphs.
Было непросто.
Thank you.
Вот, и
was not easy.
поверхностный. Скажите, какой конкретный пример
A very
решения
superficial
такой
question.
задачи или технической
Any
задачи
example of a business or tech
позволяет этот
tasks
инструмент реализовать?
for this tool?
И в дополнение, не является ли большими накладными расходами создание вот
Are there
этого
big overheads
знаний для
to create
решения
this knowledge base?
задачи? Какая
to solve the
практическая
problem?
задача и не сложно ли
What's
всё
the
это
practical task here,
реализовать?
and isn't it too hard to implement?
Пример ёмкий какой-нибудь.
Да, простейший пример — это...
A simple example.
Да, то есть...
Deduplication.
Вот прям, мы его попросили, то есть у нас есть некоторый граф, да, мы
We
описываем,
have a certain graph.
даже не сильно заморачиваясь с этими, там, чтобы полностью описать.
Without, digging too deep into the description of the subject base, we're saying that if the entity has this and this and this
Правило, то это одна и та же сущность.
kind of connections, this is the following entity.
А корпус знаний готовите вот эту базу, да,
But your knowledge base,
или где-то
preparing
готовы?
predicates, entities, or it's already made.
Это уязвимость.
Our knowledge base is vulnerabilities.
Спасибо большое.
Okay.
Давай прям быстренько выберем, какой
Thank you.
вопрос тебе больше
We'll
понравился.
quickly select the one question that you loved the best.
Я бы второй, честно.
I would pick the second one.
Пожалуйста, передайте там, помашите ручкой, чтобы вам пришли приз.
Да.
Wave your hand.
Тоже получим.
You'll get a prize.
На правах рекламы Z3 Zettelkasten.
Let me
Возможно, вам будет интересно.
advertise Z3.
Очень классно.
Maybe you will
Продолжим.
find it interesting.
После.
Loved it. Let's continue.
Прям услышали про новую технологию в теории.
You heard about this new tech in theory and in
После
practice.
этого у нас будет про
Now, the next thing coming
автоматизирование
is
ML. То есть ML, у нас
ML
следующий,
automation.
мы его будем автоматизировать. Увидимся.
Now we're gonna automate machine learning. Great.